Assalamu alaikum everyone. Today we are going to conduct lecture number 16 of this online course, and today's topic is addressing mode. This is going to be third lecture on addressing modes. We have covered two lectures before on this topic and covered significant amount of uh, topic. So we will try to complete this topic in this lecture. Okay, this is just an starting slide and we are going to redefine addressing mode. So addressing mode can be defined as a number of ways in which processor can access data operands. So there are three types of addressing modes. We have already know them now. Number one was register operand addressing mode. We have covered it. Number two was immediate operand addressing mode. We have also covered it. Third is memory operand addressing mode, and we are covering this specific memory operand addressing mode. Well, in memory operand addressing mode there are again number of types. So direct memory addressing mode, we have covered it. Register indirect addressing mode, we have also covered it. And based addressing mode, index addressing mode, and based index addressing mode. So these three will be the topic of this lecture. We will be trying to examine the fact about based indexed and based indexed addressing mode. So let's proceed the topic. Okay, memory operand addressing mode. So like any memory operand addressing mode, one of the operand in the instruction must be a memory or memory location, and whenever a memory location is involved in an instruction, then we need to know that there must be some calculation of physical address of that specific memory location. So in based memory operand addressing mode, that physical address calculations involve effective address, and effective address will be sum of two things. Number one is content of base register, and that can come either from BX register or base pointer register. And the second thing which is involved in effective register is displacement, and that is a number. It can be either 16-bit or 8-bit. So these two informations, base register or displacement, both these information must be given in instruction, and these will actually help us to calculate the physical address of memory operand. Okay, in this diagram one can see this thing, physical address. Physical address is equal to segment base address. So this part is segment base address colon, and then this whole part is effective address. So this complete part is combination of two things. One is base and other is displacement. So this part, which is segment part, is going to be coming from these segment registers. It can come from CS, TS, SS, ES, and then effective address will be calculation of will be summation of these two things, base register plus displacement. One thing more we need to discuss, base memory operand can be analyzed using a one-dimensional array, which is shown here in this picture. We can see that it is an n element array starting from element 0, element 1, element 2, and it goes to up to element n. So there are n elements inside this inside this data array. I hope you have covered these things in data structures. So we are considering an n element array, and base memory operand is basically pointing towards number of elements. So those number of elements can be considered as array. So very first element is basically pointed by base register. So we can see that element 0 is pointed by base register, and then this displacement factor can actually reach to any of these elements. For example, if displacement is 2 and element 0 is pointed by base register, so for example displacement is 2, so that means one displacement and two displacement. So with displacement 2, one is going to access this part of this array. So complete memory operand is pointing a full array in base memory operand, but with the help of displacement is equal to 2, one is going to access this specific memory location. One can also change this displacement. For example, this displacement can be 1 as well. So if displacement is 1, so it will be pointed to this specific location, element 1. Similarly, in this specific example which is shown here, displacement is equal to n minus 1. That's why this location, this element of a complete array is being pointed towards this displacement. I hope this point is clear. We will see these things more in detail once we are going to deal with real-time examples. Okay, a segment register can be two types. It can come from data segment register, and it can come also from stack segment. Okay, in this slide we are going to deal with an example, and example is move bx plus 1234 hex comma al. So one can see that it is a move instruction, which means it is a data transfer instruction. And so there will be something which is source operand, there will be something which is destination operand, and data will be going from source operand to destination operand. So what do you think? What is this operand? Is it a register? We see here bx. Do you think it is a register? No, it is not a register. It is a memory. And why? Because we see this square bracket. Remember, I told you whenever you see this square bracket, so that operand is going to be a memory. And we here see a base plus a displacement, and this is displacement is basically 16-bit displacement since it is hexadecimal number. So base plus displacement is shown. So it is the example of base addressing mode or base memory operand addressing mode. Furthermore, the second operand is basically AL. What do you think? What is it? Yes, it is a register. It is an internal register, an 8-bit register. So this operand is basically source operand. So source operand is AL, which is 8-bit register. Destination operand is a memory location, and furthermore, effective address of this memory location is combination of two things. It is base, which is bx register, plus 1234 hex. It is a 16-bit displacement. And one thing more which is important here, and its operation size. So size of operation in this instruction is 8-bit because only 8-bit register is involved. So 8-bit information will going to move from this AL register to this memory location, which is pointed by bx plus 1234 hex as displacement. Okay, let's say ds value is equal to 0200 hex, bx is equal to 100. So physical address can be calculated as ds will be treated as segment prefix because we don't see here any specific segment prefix. So ds is a default data segment, so ds will be used, and effective address will be combination of bx plus 1234 as we discussed in base memory operand addressing mode. So we are going to put the values of ds value is 0200, furthermore bx value is 100, plus this displacement. First of all, we have to add these two values. Once these values are added, we have to multiply this segment base address by 10, and then result will added into this result. So overall result will become 04234. I hope this thing is much more clear now because we have seen this example, or we have been practicing this physical address calculation since last number of lectures. So this procedure must be clear to everyone. So what going to happen? The source of AL, the content of AL register is going to be copied in memory location whose physical address is 4234 hex. I hope this complete example is clear to you. Okay, here we see a book example of this instruction: move bx comma 1234 comma al. It is the same example that we discussed in the last slide. So this specific portion is memory slot which is attached to microprocessor. This rectangle box is microprocessor itself. So physical address of this instruction can be calculated using IP and CS register. It is the same calculation we have performed so many times, so I'm going to skip it. The physical address calculated by these two registers is equal to 01000. Furthermore, there are four number of bytes which are involved here, so there will be four locations which will be used or consumed during the execution of this instruction. Furthermore, we have calculated physical address of this memory operand which is shown in this instruction, and the physical address was 04234. So we learned in the last slide that source will be AL register. So whatever the content of AL register, the content of AL register is ED. This is complete AX register, so this lower part will be AL register. So ED will move to this physical address, and this physical address can be seen here. So far we don't know whatever its content is. So after the execution, what will happen? IP will switch these 4 bytes. So this has been happened here. Furthermore, this information has moved here in this location, which we were expecting. So I hope this is much easy now, because we have seen these kinds of example so many times in this course. For if you have still any query, so you can note it down for the online session about this example. Okay, the next thing we are going to discuss is index memory operand addressing mode, or simple index addressing, and it is the same, almost similar. The difference is only in effective address calculation. So physical address of memory operand must be calculated, and effective address will be sum of, last time it was base register, this time it is going to be index register. So index register, we have two options: either it is source index or destination index, and there will be a 16-bit, or there can be a 8-bit displacement as well. So rest things are similar. uh, One thing one can observe here as well, that is segment based override, that is effective address calculation. So in first part is index, second part is displacement, which can be 8-bit or 16-bit. Furthermore, it is the same kind of analogy which we explain in base addressing. So index addressing is also not only pointing towards one location, but rather it pointing towards a number of locations which can be analyzed as an one-dimensional array. So we see here again one-dimensional array: element 0, element 1, element 2, up to element n. And in this example, we see here index register is pointing towards an element. So this time we are pointing towards from the last part of the site. So index register is basically pointing towards last element, which is an element, and displacement moves it towards backwards or in opposite direction compared to the base addressing mode. So we can actually cause it to move it towards up to element 0. So we're gonna see it in example as well. It's almost similar. Again, same segment register will be data register unless it is not specified. uh, okay, here we see example of index addressing mode. Example is move ax comma si plus 1234 hex. So this part is our memory part or memory location, because we see this square bracket here, and this is index register, which is source index plus 1234. It is a 16-bit displacement, and that thing is AX. It is going to be our destination operand. So destination operand is AX, source operand is memory location, and effective address will be calculation of summation of SI plus 1234 hex. So let's assume if data segment is 0200 and SI, which is source index, is equal to 2000, so we can calculate physical address as data segment, which will be used as a segment based address, colon effective address, and effective address will be summation of SI plus 1234. We have just put the values as we put in the last slide, so DS value and SI values are set here. Furthermore, this 0 is just after multiplication. That's the result of multiplication by 10. So I hope this point is clear, and once we calculate the complete result, it will become 05234 hex. So the content of this memory location, right, which is pointed by index plus some displacement, or index is source index, so that location is pointing by these two, so this location is pointed by these two values, so index plus displacement. So this location's content will be going to copy and they will go to AX register. Okay, we are going to cover a book example again for this specific addressing mode, which is index memory operand addressing mode. We're gonna deal with same example that we covered in the last slides. Move AL comma SI plus 1234. We see here again it is the combination of 4 different bytes. IP and CS are pointing towards same physical address, and these 4 bytes will consume during the execution of this instruction. Furthermore, we see the physical address we calculated, so that is our source, and that is going to be this source operand. So the content is BE, so this BE will move towards what AL here we see here, that is basically AL. So after the execution we can see these changes here. BE has moved here as we were expecting, and IP has switched to these 4 locations. These 4 locations are skipped because those locations are already consumed during the execution. I hope this thing is clear. Okay, now we are going to discuss very last addressing mode, which is base index memory operand addressing mode, or simply base index addressing mode. Since it is also part of memory operand addressing mode, so it combines base addressing mode and index addressing mode. So this index addressing mode can be considered as combination of both these two modes, base addressing mode and index addressing mode. Likewise, we were calculating physical address of memory operand, so we will be following the same fashion here. So effective address of that physical address will be combination of this time 3 things: context of base register, content of base register, which can come from either BX register or base pointer register. Second thing is content of index register, which can come either from source index or destination index. Third thing is 8 or 16-bit displacement, and all these 3 things which will be given in instruction. So one can simply understand it how it combines the 2 modes. In base index mode, in the base addressing mode, we had only base register and displacement, while in index mode we had index register and displacement. But in this mode we are combining these 3 things, and this can further understand from this diagram. We can see here physical address is calculating by segment override which come from these 4 segment registers, and then this effective address part. One can clearly notice that there are 3 components. First is base, second is index, and third is displacement. So that's how physical address of memory operand will be calculated. Again, segment register will be data segment register unless it is specified elsewhere. Furthermore, this diagram is again indicating that this addressing mode also refers towards number of memory locations, so we can also analyze them using an data structure array, but this time it will be two-dimensional array because we have 2 different variables. One is coming from index register and other is coming from base register, while displacement is a constant which can vary across the domain of these two-dimensional array. These things can be understood while we are going to deal with example. Okay, we are going to consider an example in this slide. So example is move ah comma bx si plus 1 2 3 4. We see here 2 different operands in this instruction. This is our destination operand, that means it is a register which is ah in this case. Then latter part we can deduct it from these square brackets. This part is memory operand, and we see here 3 different components: base register and index register, and we see an addition of displacement as well. So destination operand is ah, source operand is a memory location, and this time effective address of this memory location will be combination of 3 things: base plus source index plus 1 2 3 4, which is a displacement in hex. So let's consider if ts is equal to 0200 hex and bx is equal to 1000 hex and source index is equal to 2000 hex. These are just dummy values we are going to consider. So physical memory of this physical address of this memory location can be calculated using this equation. So ds colon bx plus si plus 1 2 3 4, we know that this is our effective address part and this is our segment base. So since there was no override mentioned, so we need to consider that is the memory location which belongs towards data segment. Then we're gonna put the values. Data segment will be 0 to 0. Similarly, bx is 1000 and si is equal to 2000. So if we're gonna calculate, it will be equal to 06234. So this is a memory location which is present. What gonna happen in the process? Whatever the content of this memory location whose physical address is 06234 is going to copy it inside this ah register, and I hope you understand it is going to be an 8-bit operation because destination register is an 8-bit register which is higher byte of AX register. Okay, in this slide we are going to see a book example. We have seen already this statement in the last slide: move ah comma bx si plus 1 2 3 4 as an example of based index addressing mode. What we see here is IP value is 00 and CS value is 0100, and both of these register point to this memory address. We have seen this calculation many times, so I'm not going to explain it. Another point which is important to note here, there are 4 different bytes which are involved in this assembly instruction. What we are going to happen, this memory address is pointing towards certain memory location. We calculated in last slide that address was 06234. the content is BE, so that address is going to, that value is going to the value of AH, and AH in this case we don't know whatever the value of AH. So let's see what happened after the execution. These 4 bytes are consumed, so IP has switched to this memory address and this value has been shifted towards AH as we were expecting. So I hope this example is quite easy after doing these such examples so many times. So that's how a base index addressing mode works in 8086 or 8088 microprocessor. Okay, in this slide we are going to see different examples and we are going to determine what specific addressing mode is being used. For example, first example is move AL comma BL, and in this instruction we see two different operands. BL is a register, AL is a register, so this is going to be a register operand addressing mode. I hope it's quite easy. In this next example we see a direct value is being used as a source operand, or a direct immediate value is being transferred to this index, to this destination register, which is AX. So this is immediate value and this is a register, so this specific addressing mode will be known as immediate operand memory mode. I hope it's quite easy. Immediate operand addressing mode. In the third example we see a direct address is given, and this square bracket indicates it's a memory operand, and direct address is given of effective address, so this is going to be direct memory operand addressing mode. Fourth example, we again see this square bracket, which means it is a memory operand, but uh, this time direct effective address is not given, rather source index is given and direct address is stored in that register, so this is going to be register indirect memory operand addressing mode. The next example, example 5, it indicates that there is a square bracket, so it is going to be again memory operand addressing mode, and this time we see base plus this displacement of 16-bit is shown. That means it is based addressing mode or based memory operand addressing mode. Similarly, sixth number is an index register is shown plus a displacement, so it is going to be index memory operand addressing mode. And the last example is base index, because we see both part base, index and displacement in a memory operand, so the last example is base index memory operand addressing mode. So I hope these examples are good to recall each and every addressing mode we have covered. Okay, that's it from this lecture. We concluded today a very important topic of our course, which is addressing mode. I hope I have explained things in detail very clearly. If you have any queries in your mind or any thing which you did not understand, please note them down. We are going to discuss those things in our online session. Thank you so much for listening.